Today I shall discuss the governing of steam turbine. The governing of steam turbine. What is governing and what is its application? Now consider a turbine run by steam. The steam is supplied to this turbine and shaft is rotated of the turbine, and by the generator, this is the generator which produces the electricity. This electricity is supplied to a locality, and the person of the locality runs the TV, AC, fridge, light, fan, etc. All the equipments they can run. But at the winter, when the AC, fridge will not run, the load of this locality will reduce. Load of electricity in the locality will reduce at the winter, and the summer time this all the equipments will run, therefore it will be higher at that time. So this fluctuation of this load causes the change required to change the rotation of the turbine. That's mean when load is low, therefore at that time the generator not required to run to produce so much electricity. When generator producing low load, at that time turbine not required to run higher speed. During the winter, when load is low, at that time the turbine not required to rotate at higher speed. So to reduce this speed of the turbine, the steam supply should be reduced. And when the load is high, at that time the generator will produce more electricity by the application of this steam. So this control can be done by the governing. Actually what happened, when the load is low, the generator back EMF will reduce. The back EMF will reduce and the turbine will try to rotate higher speed. But if we supply the steam low amount to this turbine, then automatically speed will reduce and therefore it will control. So by the governing we can control the flow rate of steam to the turbine to control the speed of the shaft. Okay, therefore the governing is the process of controlling the flow rate of steam into the turbine to control the speed of the turbine is called governing of steam turbine. The important types of governing of steam turbine is throttle governing. Throttle governing. Now you can see that this is the spindle. This is the throttle governing. This arrangement is the throttle governing, and this is the turbine. Okay. Now consider during the winter, when load will reduce, the generator not to supply the huge amount of electricity. At that time, the back EMF will reduce, and therefore turbine will try to rotate higher speed. When turbine will rotate higher speed, further I am saying, when the load is reduced, the turbine will try to rotate higher speed, and therefore this rotational speed will go through the bevel gear, and the spindle will rotate higher speed. As the turbine is rotating higher speed, the spindle will rotate higher speed. When it will rotate more speed, then fly ball will try to go outside. This will move in this outside. Therefore, what happens when the ball will try to move outward due to the centrifugal force? This is called slip, will move upward. It will move upward. When it will move upward, this point A will go upward. This will move upward, and this is fixed, and B will try to move downward. When A will move upward, the B point B of this lever, this is the lever, this lever at this point B will try to move in downward. When it will move in downward, this is the valve which move in downward direction, close the nozzle, and flow of steam, the steam in through the nozzle will closed, and this area will closed. As this area will close, the steam not able to exit from this nozzle at maximum amount or more amount. Therefore, the less amount of steam will transfer to this turbine. Therefore, the turbine will rotate less speed. I am saying further, when generator not working or not supplying huge amount of electricity, the turbine will try to rotate higher speed. When it will be high, the spindle speed will be high, and therefore the fly will go outward direction. Therefore, this slip will try to move upward, and when it will go upward, the B will go downward. And when it will move, this valve will try to move downward direction. The area will closed, and the amount of steam supply will reduce, and therefore the turbine will rotate less speed or low speed. This is the process of governing. Okay, I am writing further. When load of electric supply reduce, the turbine speed will increase and bevel gear speed will increase. Therefore, spindle speed will increase. So, fly balls go outward due to centrifugal force. Now, when load of electricity supply is reduced, the turbine speed will increase. And bevel gear speed will increase. Therefore, bevel gear speed will increase. Therefore, spindle speed will increase. So, fly ball go outward due to centrifugal force. The fly ball will go outward due to centrifugal force. At that time slip go up. This is a slip. When fly ball go outward, this is the weight which will go outward, the slip will go upward. When slip go upward, the point A of lever AB go upward and point B go downward as lever at point C is fixed. See that when A will go upward, B will go downward, because at this point C is fixed and pivoted. Pivoted means this point is fixed, but this lever can go this direction or this direction. It can move. Rotational motion is there, but at this point this lever is fixed with this support. When point B go downward, the valve go downward and close the area of the nozzle. This area will closed and not able to transfer the steam through this nozzle. and finally reduce the speed of the turbine due to reduction of steam supply. So reduction of steam supply, this reduction, the steam supply will reduce and the turbine rotation will reduce.